Good morning, everyone. My name is Brian Lee. I'm the coordinator of the Resilmesh Cybersecurity project, Horizon Europe project. And today, with some colleagues from Scientific and Synesis, who are managing daughter projects, FSTP projects, we want to share some capabilities that we are excited about within Resilmesh and the projects that we believe can enhance cyber defense operations in large distributed environments over the coming years. And so let me just share my screen and share some slides with you on that topic. I should draw to your attention that this webinar is being recorded. Can you see my screen? See?
Yes.
Okay, great. Okay, the title of our webinar is Connected and Interoperable, a mesh approach to dispersed and edge infrastructure cybersecurity operations. And we'll delve into what that means as we progress through the webinar. So our agenda today will be to discuss security challenges arising for distributed infrastructures arising particularly from IT-OT convergence. Then I will talk a little bit about how the parent Resilmesh project provides capabilities to do that. So we will look at how we support operations both within the managed domain, but also within the cybersecurity plane itself. We will then focus in on two specific aspects of that. One, where we will look at how in depth, how we provide support at the connectivity layer 3 and layer 4, to improve resilience and more reliable operations. That will be introduced and presented by our colleagues from Synesis in the CHAMELEON sub-project. And then we will move on to discuss how interoperability between distributed security controls can be enhanced using open source techniques or open, well-addressed techniques. That will be addressed by the XMesh project, and they will focus particularly on cyber orchestration. We will have some time for questions and answers at the end, and we hope to wrap up in about 45 to 50 minutes. So what are the challenges we want to talk about? Primarily, we want to consider or to think about what the impacts of the convergence of IT and OT is having on large distributed networks. Another way to think about this, or the term that's sometimes used, is called softwareization of infrastructure. And we can see that that is happening more and more now within distributed infrastructures. In particular, we can look at the telecoms network, where this has been ongoing for a number of years through network function virtualization. This has been discussed for many years within telecoms networks. But we're also beginning to see it more and more within more mainstream critical infrastructure operations, where assets are becoming software-defined and virtualized. We can see that this is happening. Well, it's been beginning to occur and experiment with quite a lot within the critical infrastructure networks, particularly within the grid networks, where endpoints such as smart meters, EVs, and interestingly, and more increasingly now, substations and larger granularity endpoints. These are in the early days. You can see several announcements from vendors and operators this year, where the grid operators and transit TSOs are beginning to experiment with this capability. But more and more it is happening, and more we expect to see it grow. One of the consequences of this increased softwareization of the infrastructure is going to be the ability to deploy more comprehensive and more capable functionality. And so one of the trends we're seeing there is that AI is moving towards the edge. This is occurring all across distributed infrastructures. It's occurring within edge to cloud continuums in enterprise networks. And again, we're beginning to see it more and more so within smart grids as well. One of the main examples of that in critical infrastructure networks is the use of smart cameras for both physical security, but interestingly now also being used a lot for fire detection, particularly in remote areas or remote parts. You look at some of the big US utilities who operate across very large, wide areas, sparsely populated. And also now within Europe, we see that that is occurring. But also these capabilities, these edge AI capabilities are being used to monitor the operation of the grid itself, and to have a more distributed monitoring and reaction time. A follow-on consequence from AI moving to the edge and softwarization of the platform is that cyber defense is now also beginning to move to the edge. And you can see this again in vendor announcements and in trials with service providers. One interesting one is a joint offering from SAP, the German firm, and Intel, which combines Intel's edge processing capabilities and SAP's cloud platform to provide an edge cloud-based cybersecurity monitoring system. Again, focused primarily on smart grids, in particular at endpoints such as EVs and substations. And so the consequences of this are that attack surfaces are expanding all the time as networks become softwarized and as edge, vendor, and customer-side systems become more connected and internet exposed. And so should not over-amplify this. This is in its infancy. Yes, it's quite true. You can see that for a few years, PLCs have been more and more embedded with web servers and becoming more intelligent. But the distribution of that functionality out to the edge and the gradual softwarization of the networks is really in its infancy. But it's a trend we expect that will increase and will become more common over the coming years, and indeed will accelerate. And so it's towards that vision of softwarized networks and the operation of cyber defense within those networks that we want to look at today. That is the focus really of what we want to talk about. But before moving on to see how we address those challenges, let's take a little look at some of the reality that's happening around threat models and threats within the networks themselves. This is a slide from a white paper released by Renewable UK, the Organization for Renewable Energy in the UK. It shows the frequency of Russian hybrid attacks in Europe from 2018 until 2025, until the end of June 2025. That we don't have any figures thereafter. And you can see that there has been quite a dramatic increase in the last 5 years, 5 to 10 years, not just in the number of attacks, but also in the scope of those attacks. In the early days, it was focused on government, the odd energy thing. But now you can see here that in 2024, a lot of the attacks were actually on water utilities and undersea systems. So threats are growing. Here are some recent releases from different associations in the smart grid space talking about security. The OT ISAC released a report in April of this year, which points to rising energy sector risk as the exposure spreads beyond the control room into distributed assets, which fits very much with the idea of more intelligent and softwarized distributed energy resources or distributed assets. Exposed OT assets remain the highest priority class, they say. Some other papers from that point to the same thing. On the right, we have a new security guidelines from the North American Electric Reliability Corporation, which is responsible for setting standards for grid operators in America. They're updating their security guidelines for the first time in about 7 years to reflect growing threats. On the left, we see some risks and some technologies that can be impacted from increasing and expanding their attack surface. This is in a white paper from a vendor called DERSEC. It's quite an interesting paper in how it looks at these things. And then finally, going back to the Renewable UK again, they published in March of this year quite a broad analysis of the UK of cybersecurity, not just of cybersecurity, of resilience in renewable energy networks, including cybersecurity. One of the interesting findings is that they're pointing about the need for operators to consider new distributed threat vectors. So in summary, what are we saying? We're saying that networks are beginning, that softwareization and IoT is now beginning to creep into the smart grid. It's now being trialed by a lot of operators. It's a trend we expect will scale and will scale fairly rapidly. And we can see that it's already reached the point where the authorities or the trade industry or the people responsible for regulation are beginning to flag that this today is a real risk. So we anticipate that trend towards softwareization is going to dramatically increase over the next few years, as is the rise in risk. And so what we want to talk about here today is how does we want to look at two aspects of how we believe Resilmesh can help support and meet these challenges. We don't at all propose or suggest that Resilmesh is the answer to every question and has all the answers by any means, but we do want to focus on two aspects we think will be a big help. So let's talk about Resilmesh. Resilmesh was created to address dispersed heterogeneous cyber systems. Project is in its final year and finishes in November this year. So the basic concept behind Resilmesh was to take cyber situational awareness and to see how that could be used. So on the bottom at the left here, you have the well-known cyber situational awareness framework, which is perception, comprehension, projection. We couple that with decision and action, and then we more or less stood that on its head and mapped that into a cybersecurity stack. So at the beginning, we have the data coming from the end nodes. We go through aggregation, we go through threat analysis, threat awareness rather, situation assessment. And what we don't show here is on the top is our operations plane. Underpinning those, we have something called the collaboration mesh, which serves to have better interwork between all the components. And it's really about the collaboration mesh that we want to speak today. So Resilmesh provides support for security management for dispersed infrastructures. It does that primarily for the managed domain, which is what its function is. It also provides support for the cybersecurity plane and for resilience in the cybersecurity plane. And that's the scope of today's discussion. But before I jump into that, let me just mention how we had a webinar with the Synapse project maybe 2 months ago, where we looked at how Resilmesh provides support for the managed domain. And by managed domain, I mean the actual enterprise or organization that you want to ensure that the business continues there. So it does this through a combination of cyber situational awareness, which is primarily based around asset management and dependency management. And it does that in combination with dynamic risk management, which looks at network risk assessment based on the information from the cyber SA, and then informs the autonomous risk mitigation. So that's an interesting subject, and how the two projects handle it, you could explore further in that video if you really want to. You will find that if you look on YouTube, search for Resilmesh, you'll find a lot of our videos there showing in more detail what we do within the project. But jumping ahead to our support for dispersed infrastructures, there are 3 legs on this stool. If I look at the right-hand side, our first capability is around edge operations. There we provide a number of solutions for edge anomaly detection, looking at network traffic, among other things. We provide support for edge CTI through another of our STP projects. And finally, then, we believe that we provide support for zone-based IDSs. Although we do not, at this point in time, implement that, we do have the capability to build on that to see. So with the other 2 legs of the stool, the first one is around communications resilience, which is looking at resilience in layer 3 and layer 4. We look at 2 things there within the project. We're looking at around operations continuity and the issue of moving target defense, and how that can be used to make the system more resilient is explored in CHAMELEON, which we will come to in a few moments. The second part, as I said, was interoperability between security controls. There we're looking at how we can use or implement principles from the Gartner cybersecurity mesh architecture, and also from work being done within OASIS, particularly within the Open Cybersecurity Alliance, OpenXDR. These form our collaboration mesh. This first part, which is the communications resilience, will be explored in more depth by CHAMELEON, and the security excuse me, interoperability between security controls with regard to orchestration will be considered by the XMesh project. So let me say a little bit about first within the project itself. Our basic idea is on the collaboration mesh was that we wanted to improve resilience in the SOC infrastructure. Remember, we're anticipating a highly distributed SOC infrastructure. We want to improve the capability to improve reliability of operation there, so that, for example, if communication breakdown happens, the distributed cyber controls can still continue to work effectively, and also to build defense capabilities into that. At the second and top layer, which is the application or layer 7, we want to consider how we can improve interaction, interoperability between security controls, including the incorporation of third-party controls, not just those we develop in the network itself. So we want to look at principles of standardization, composability, et cetera. So at the bottom level itself, at the connectivity mesh layer, we use service mesh, cloud-native service mesh architecture to improve resilience and control. Most of you will be familiar with products such as Istio and Linkerd. However, we're using NATS as our basis for communication. So NATS is a message broker, like Kafka, for those of you who maybe not be familiar with NATS. It allows us to place functionality just about anywhere and on any type of end device. And it's a pub-sub architecture. However, NATS also provides the capability to implement a service mesh. You can see there's a link here. If you go and look for NATS and service mesh, you'll find it. Full details. But that gives us capabilities like load balancing, communication resilience, security observability. And this becomes then a platform for the CHAMELEON project on which to build and enhance greater capabilities that Professor Urich will explore in a few moments. The second interoperability mesh is again, looking at creating a collaborative system of tools and controls. It's based on this idea of composability. So what do we mean by composability? Composability means you expose either standardized or well-defined understood interfaces, which allows to connect outer products very, very easily. In fact, Resilmesh is architected very, very much around being composable. It's based on a core, a SIEM-based and asset management core, which provides a very basic threat management capability. And then it exposes interfaces, which allows us to add the functionality of more intelligent threat awareness operations, security assessment, and an operations plane. Each of those planes, you can configure Resilmesh with any combination of those. So it's composable right from the beginning and at its heart. But we did see that there are principles and concepts and ideas that were widely available within the marketplace at the time that served as a very good architectural foundation for what we wanted to do, and that we incorporated into our concept from the beginning to allow us to make the system more usable, more extensible. So one of those, as I referred to, is the open XDR architecture. So it defines a framework basically for interoperability in 4 quadrants. One is ingestion, where we're looking at the use of the Elastic standard for standardized way of managing or handling aggregation data, threat data. There we use the Wazoo SIEM. The second quadrant is automation, where it's very much focused around OpenC2. And we use OpenC2 within the project for our attack mitigations. The third is orchestration. And there the main standard, the main opening is CACAO. And this will be explored by the guys from Scientific within the XMesh project. And finally, we have the threat intelligence, or the threat intelligence sharing, which is based on STIX 2.0. Within the project, we've explored the use of something called indicators of behavior, which is the sub-project of the OCA, which looks at using STIX objects to represent not just individual behaviors, but sequences of behaviors. So you can describe and share a multi-step attack. So in summary, we expect challenges. We expect to see networks grow more capable. We expect to see more softwareized networks. We expect to see functionality being increasingly deployed throughout those networks and towards the edge. we expect to see cyber controls follow. And we then say, what are the problems that arise from that? How are the ways we can deal with distribution? We can improve both the resilience at the connectivity layer and the interoperability at the upper layer, at the application layer, which will allow this distributed SOC infrastructure to manage better and to function better. We've looked at how the basic connectivity layer is provided by the project itself, by Resilmesh through the NATS.io, and we've looked at how within Resilmesh we are using some of the standardized approaches from CSMA and OXA to provide better interoperability. What we now want to do, and what we have done, is we have financial support for third-party projects, and we want to take a deep dive into how those basic connectivity mesh and interoperability mesh capabilities have been improved by the projects. So I'm now going to hand you over to Professor Juric from CHAMELEON, from Synesis, who will talk about CHAMELEON and how that enhances the connectivity mesh. So, Matthias, over to you now. I'm going to stop sharing my screen.
Professor Lee, thank you very much. Can you see my screen?
I can. Yeah, you can go ahead.
Confirmation that you can see my screen. Okay, great. Thank you. So you can't compromise what won't hold still. That's basically the whole idea behind the CHAMELEON. And in the next 15 minutes, I will explain this sentence and explain how the CHAMELEON, as a resilient mesh communication, does its job. So as Professor Brian Lee already mentioned, and I won't go into more detail about that, I will just repeat that the workloads, so the services, applications, and the security controls that are watching them, they now run across the cloud fog edge continuum. And probably the edge is the most exposed part. And what ties all the layers together is a single communication fabric. So all the communication, every alert, all the telemetry streams, enforcement commands, and everything goes through the communication fabric. As Professor Lee already mentioned, in Resilmesh, this is called the connectivity mesh. And the question that I would like to address is, how strong is that fabric really? And one of the answers could be that the weak point is that nothing moves. What I'm trying to say is that the infrastructure where the workloads, the services, the applications run is static. And this is basically what we are used to. And most of the systems and applications work like that. And the static workloads give attackers a lot of time because they can map the infrastructure, they can map the workloads, the services, they can gain access to persistence, and so on and so on. This is one of the important questions. The second one is, of course, the connectivity mesh. So the connectivity fabric can be a single point of failure. And if the connectivity layer fails, then all the services are down, all the workloads are down. If we look at today's currently used service mesh, such as Istio, Linkerd, it is basically a service mesh that does the work on the channel. So what it does MTLS, it does routing, it does policy enforcement, and this is really useful. But the fact is that the workload that the traditional service mesh such as Istio and Linkerd is protecting, this workload is still static. Those meshes insert a proxy sidecar into every pod. So from that perspective, those service meshes are quite heavyweight, and they also introduce quite a lot of overhead, up to 90%. And from the security perspective, it gets even worse because the sidecars can be another attack surface. There are well-known security vulnerabilities such as sidecar injection, MTLS misconfiguration, proxy CVEs, and so on. And all those are basically the new entry points for the attacker. But probably the most important one is that the sidecar mesh, so Istio and Linkerd, is often too heavy to run on the edge. So to summarize, it protects the cable, but it doesn't protect what is running on it. And it's sometimes so heavyweight that it cannot be used on the edge efficiently. Here is what CHAMELEON brings to the table and what it does. It is a NATS native sidecarless service mesh that applies moving target defense to distributed security operations. And probably this sentence tells the most of it. So on one hand, it is a connectivity mesh. It uses NATS as the lightweight, high-performance messaging layer, which is configured in such a way that it is resilient and self-reconfiguring. This is an important aspect. The communications will survive because they can reconfigure. The other important part is the moving target defense part. And this is the part which makes the infrastructure of the system, of the workloads, dynamic. How we achieve this? So basically, we call this CHAMELEON pod defense, and it is a practical implementation of the moving target defense. And there are three important parts. What we have done is that we have introduced a Kubernetes operator that recycles pods in short, randomized time to live in intervals. So a pod is not running for days or weeks or months, but lives only for a few minutes and then it's gone. An attacker will not have enough time to actually explore and attack the pod because it will move. Not only will it move, but it will also mutate. So each new pod comes with a configuration jitter, some randomized parameters, and no two replicas are identical or equal, which is also important because it breaks the cycle and prevents automatic exploits that depend on some stable fingerprinting and so on. And finally, the final part is deceive and detect. So we not only mutate the pods, but also generate honey tokens and honeypots and integrate them into the fabric and the workloads. So these are basically the decoys with no legitimate reason to be touched. And the moment one is touched, it will fire high fidelity alert on the mesh itself, and an intrusion will be detected. And the important part here is to understand that the intrusion is detected from the inside of the communication layer. It is not bolted from the outside. And probably the most important takeaway from this slide is that this isn't only detection, it is basically prevention. Because by the time an attacker has mapped the system is already gone. It has moved, mutated, but it still runs because the NATS service mesh reconfigures to the new ports and all the communication stays intact. Maybe you are now asking yourself, okay, if the ports are tearing down every few minutes, and they get reconfigured and so on, how do we not drop the messages? How do we achieve that the communication is still reliable without losing messages? The answer is that the NATS layer, which is configured in a way, so we basically use Jetstream reconfiguration and routing. We use queue groups and we use graceful draining. And all those concepts together allow us that when a pod drains and leaves, the broker instantly reroutes the healthy replicas to the same queue group. And the system just continues to work. So no central routing, no table update, and most importantly, no lost messages. And what I also have to point out is that it's a sidecar-less approach. So in contrast to Istio, Linkerd, and other service meshes that use sidecars, the NATS approach is very lightweight. It does not use sidecars, and it has much, much lower overhead and a much smaller attack surface. If we now look at the architecture more into the detail, we can see that the CHAMELEON architecture consists of 3 planes. So the control plane, this is where the CHAMELEON pod operator, this is a specialized Kubernetes operator. It has a reconciliation loop. It has the algorithm implemented to enforce the randomized time to leave, the configuration jitter, eviction, and so on. And it does the rotation and movement of the pods. The data plane is sidecarless, so basically HTTP requests that come through ingress go to the front-end bridge, and that front-end bridge translates this to the NATS messaging. So the standard HTTP communication is still open, and you can still use traditional standard REST APIs or other means of communication. But from that front-end bridge beyond, the communication relies on NATS, so on the subject routing, queue groups, and everything that I have already explained. And then there is also the telemetry plane, which basically feeds the Resilmesh aggregation. There are the Falco runtime that emits honey token alerts, Prometheus metrics, and vector aggregates them and feeds the Resilmesh aggregation plane the sensor reference point. And this is basically the architecture and the idea behind. So before I conclude, the CHAMELEON is not just an idea. It is a working technologies. It is a working technology which we are right now finalizing within the Resilmesh and demonstrating its usability. It is reaching TRL 7. And it is basically not limited just to Resilmesh, but it can be used with any Kubernetes native environment, either on-premise or in the cloud. And it also consists some of our previous developments from European projects such as Interstore and Nefel, where we have already worked on some of the building blocks of it. Thank you very much. That's all from my side, and I'm handing back the word to Professor Lee.
Okay, thank you, Matthias. That was excellent, interesting presentation. I'm now going to hand over to TAXII from Scientific to tell us about XMesh. Matthias.
Thank you very much. Let me see. Share. Yeah.
We can see the screen, it's fine.
Perfect, thank you. Let me minimize a few things so that I can also do the full screen. I'll move it up here. Perfect. So my name is Mateusz Zych. I'm from Scientific, and we represent the XMesh project. As Brian already introduced, we are dealing with the interoperability side of the project, and we do it in two different levels. One is the standard-based orchestration, so we support automation on the standard-based, and second is on the platform side. So we try to standardize the setup of the platforms and create usable platform assets. So we can try to generate them so that it's a lot simpler to spin things up. This is very briefly, so we are going to more deeply into that. In order to support these two things that I just described, we have came up with 5 objectives that XMesh covers. So first of all, we have the objective of the native CACAO generation and execution within Resilmesh. So this is the part of the standardization where we where we support CACAO Playbook, which is the one and only right now open source security automation orchestration standard. So this is a standardized way of saying how you should operate within cybersecurity to perform cyber operations. And by having a standard, we are interoperable in that way that everybody know the standard and can support it. So it's make it a lot easier to exchange with the standard operating procedures between the constituency. So in this first objective, we support these two with providing 2 tools. One is CACAO Roaster for creating, architecting the CACAO playbooks, and second is the execution engine behind for actually executing these CACAO playbooks. Second objective is the interworking mesh for different tools within the Resilmesh platform. So this is what we are going to go more deeply today inside to see how we can utilize the newly emerged almost standardization tool for creating integration within a platform. Third objective is to enhance the CACAO interoperability by providing integrations. So in order to orchestrate tool, you need to have integration, you need to have communication to the external APIs, to the external parties, right? So we, within this project, has also automated this part so that we can have these integrations pre-made and simply drag and drop them in the architecture when we're creating the playbook. So this is going to speed up the incident response tremendously when you need to create new workflows. Then one of the objectives is to show and validate the standard, cross-standard collaboration and the cross-organization collaboration with the standards to show the interoperability And as we do it on the standard basis and we contribute also to these standards, we bring feedback from Resilmesh up to the standardization bodies. So let's start with Meshroom. Meshroom is a tool that helps you to create integration within your platform. So it separates in two different planes, as you can see on the upper left image. You first describe your capabilities. This is what a vendor is supposed to do. We have tool A. Tool A performs capability A, B, C, D, E, F, G, and we have these fields that we need inside and are required. When we have these descriptions for all our tools in our platform, then we can simply also identify and connect these tools together, because we have tool A have a trigger with this particular topics for this particular purposes, and this is supposed to connect to tool B having capability, but on the opposite side. So when it's a trigger, then it needs to be executed. This creates the ready-to-use integration between the tools, so that when you actually want to utilize these tools within your project, you can simply pull down the descriptors, you create the integration between those projects, and you can simply spin it up. So the first step here is, yes, you need to create all these things, and it will be time-consuming to define every capabilities for those tools. This is supposed to be on the vendor side, and then you need to create the integrations between those tools. So this is where your platform infrastructure comes in. So then you can spin the full platform up. So let me show you an example right here. So when we have one platform, should we use Meshroom? Because now we have a lot of preparing work to do before we can spin something up. So for a simple project that have only one infrastructure, possibly that will be not the best approach to do. However, if you have a platform that aim to be reintegrated, re-spin up on different in different organizations, and those organizations may also have different tools connecting to your platform. So for example, you have cyber threat intelligence. One project may use OpenCTI, the other project may use MISP or even other platforms, right? This needs integrations. So in this particular use case for the Meshroom, the integrations still need to be created. However, you have already created your part. You know that in your platform, you are going to use this tool, and you are expecting this kind of capabilities and this kind of data to be sent in. So that make it easier to exchange the tools, as you have standardized the whole, let's call it, path between your tools in your organization. So for example, when you have your generic Resilmesh services, you expect, for example, that some service will send to you a security alert, right? So right now, we can have on one organization, this is Wazoo that is going to be connected to our tool to send this topic with this data inside. Whereas in organization 2, they are not using Wazoo. Right there, they want to utilize EDRX, right? So, or some kind of EDR system that want to send also this information because they have these capabilities. As long as they connect to this topic with this particular data that you require in your system, from your side, you don't need to do anything more, right? This is on the implementer side to be coordinated there. So once you have created the integrations and the definitions, this is the one-time thing that you need to do. Then you can simply spin the project up and down as many times you like, as extremely quickly, because now you have everything automated inside there. So this is for the parts of the platform integration and the communication within the system itself. So now we also add to that our SOAR capabilities. So security orchestration, automation, and response. It's where we focus on CACAO, the open standard. So we have our path, which is used within our mesh and our platform. But then within our platform, we still have our SOAR automation and response tool. This tool has different purposes, right? The first one is spinning up, preparing our capabilities and preparing the platform to be up and running. You can also use it as well for communication between the components. And then we have our SOAR tool that are actually performing the incident operations, so the incident responses. That means that, for example, you have your WASU, you've identified an alert, then you go over to our SOAR platform, which combines of two parts, right? You may even either execute a playbook when that you have created previously and it's ready, or you can go to the roster, to the web application to create the playbook, create the automation flow, and then you can automate the responses later on, right? And this is in a standardized way so that you can also exchange it with your constituency. So to differentiate these two, right? First one is more platform architectural thing, integrations. Second is cybersecurity operations. To enhance our cybersecurity operations side, right? Because as I told you here in the step number 2, you need to create your playbooks. In order to create your playbooks, you need to know what you need to orchestrate, and you need to know how to communicate with that. So for that purpose, we have developed our AI-assisted pipeline so that we can simply parse the open API specification of different tools, and then we auto-generate CACAO integrations. So right now, you will have a list with all the integration inside. You can simply filter by the name, by the description, by the vendor, and you can simply drag and drop. So if you have a company X firewall, the block actions, you will find it there. You can simply drag and drop. And now you have saved a lot of time and a lot of expertise to create this integration with that tool to actually block an IP. Because all the details with these CACAO playbooks will be now auto-generated. So you will have the target server, you will have the API, you will have the commands, you will have the parameters, you will have the authentication information inside there, right? So everything is prepared, almost ready to be used. Of course, your credential you will put to yourself, right? But they have variables connecting to these things. So some infrastructure details need always to be put in, but the overall creation will be tremendously shorter. So this is part of the SOAR platform that will be directly ingested into the Resilmesh platform, connecting with the mitigation manager over there and to be able to create and execute the playbooks. So to summarize here, these two concepts, when you first hear about them, may be a little confusing where to use them and why they differ, right? So here's a little cheat sheet. So when should we use Mushroom, and where should we only use SOAR, right? So for the SOAR, we have one stable SOC stack. We have a capable SOAR that can do many things. We have connectors that we have already inside our SOAR, and we can auto-generate them. We don't have any repeated onboarding, right? So we only execute actions, and we don't need to do onboarding of new components in an infrastructure. So this is where you utilize the SOAR. However, if you have many sites, so you are MSSP, right? You want to spin up this project in many different organizations, then Mushroom is of value here, huge value here. Because as we said, you can define your capabilities, and then it is extremely quicker to change between vendor A or vendor B that will provide this kind of information for your platform. Products that change over time. It's fine. It's good to use Mushroom, as I just mentioned. Direct flow exists outside SOAR. So if you have some procedures that you do day by day, just put them also as connectors or as called plugs in the Mushroom. And the artifacts must outlive SOAR. So the playbooks may change, right? Whereas your connection should be more persistent. So concluding, interoperability is not a connector problem. It's capability, contract, deployment, standards, validation, and operation problem. So there is not simple one answer for interoperability. We have many things we need to align to. And that would wrap up the short presentation of our project. Thank you very much.
Okay, thank you, Matthias. Matthias and Matthias, thank you both. So that's it from our presentation, an outline of the problems that we see. I guess both technologies, as the guys pointed out, are applicable outside of Resilmesh, are applicable outside the scope of our distributed systems that we're talking about. But we want to show within the Resilmesh context, within the context of very large infrastructures, how these tools can, how we believe these tools can contribute to what we believe is the emerging software-based networks and the distributed cyber defense within those. So that's it. That's all we had to say. Well, if there were any questions, we could take them now, if anyone has any from the panel or from the audience.
Hi, can you hear me?
Yes.
Yeah, thank you for the presentation. It's very, very interesting. So I work with the public sector, right? And I actually deal with HSE. So just want to understand how can Resilmesh can actually help government organization where part of the infrastructure is on premises, part of it is on the paper, part of it is on the different sorts of cloud. And at the moment, there are only like Sentiel and another organization which supports them. So I'm very kind of curious that the way cyber attacks are increasing and what has happened in 2021 and 2023, it should not be repeating. So how can we utilize what you're doing? How can we utilize it in government organization or within the public sector of Ireland?
Yeah, I think I could address that on sort of two levels. I think in the first case, the Resilmesh platform can be highly distributed. So using NATs, you can put components of it wherever you want. You could put some on the cloud, you could put some on premises, you could put some in third parties. The question becomes, I think, then one of governance really is what the question is, and it comes around how you enforce the particular authorization policies and access control policies. We haven't devised how one would do that, but I guess you're going to have to take some kind of OAuth approach, and you're going to have to, apply the distributed and decentralized identity management. So just as the same way as you manage, for example, it's a more general problem, I think, really. It's how you manage authorizations across cloud and how you manage on premises. It becomes really a matter of access control. And I think as such, the methods that are used within the corporation in order to allow that kind of operation itself for any of your applications, you would apply the same type of access control to the Resilmesh system. So I don't think it's a matter of, we can support and help because we allow the basic capabilities to be distributed anywhere. But we haven't specifically addressed how we would apply access controls or access control models to that kind of situation. In previous projects, we did that. We spent a lot of time working with systems like Keycloak, for example, which give you that kind of capability. But we focused our development or our budgets as such on development of controls and security functionality. So to take Resilmesh and deploy it in that kind of situation, it does need a bit more work in terms of actual deployment and actual application of access control models. So in summary, the basic architecture will allow you to deploy whatever functionality wherever you want. But what you're asking about, I think, is more about governance, and that's not something that we specifically have addressed, because we believe it's part of the broader question of governance and access control for distributed systems and cloud native in general. And the techniques used there can also be used within Resilmesh. So for that reason, we haven't specifically solved that problem to answer the question. But we do have, as I said again, the capability to deploy the functionality anywhere, but the access control is a more general problem.
Yeah. Because for me, I find it, thank you for the answer, actually. And for me, the way I am looking at it is, I find it very much capable of protecting the public sector, because moving onwards, most of it is being decentralized, and more, as you have mentioned in the presentation, more and more applications will come out. Other types of vendors will come in. So looking at the future and looking from this side, I feel that the Resilmesh will be a good fit. And thank you for giving me an explanation. It begins with where to look at initially rather than how to deploy it. So in terms of governance, as you have mentioned, that is the first place I should be looking at.
I think that's the issue. I wonder if Martin or Jorge have any comments to make on that. Yeah, I guess not. So if you have any more questions, you can always follow up with an email. You should find our emails in the. Do we have actually the email on there? Let me see. Let's share my screen.
Thank you.
Okay. No, I don't, but you can reach me at brian.lee@tus.ie if you have any questions. All right, then we'll leave it at that for now. And again, I want to thank all the members of the team for coming on board and helping out, and also to thank the participants for taking the time out to come and listen to us. You can find us on resilmesh.eu, https://resilmesh.eu. And as I said, if there's any questions, you can contact me at brian.lee@tus.ie. Okay, that's the end of the webinar. Thank you all very much.